Hello, this is Questionable Coding with Vladimir, and today we're going to cover a data structure called set. We'll cover the description of the structure, we'll go through real-world examples, we'll cover all the methods that are required and additional to this data structure, and also we'll implement it in two ways. First, using plain JavaScript, and then using a built-in set function, which is also a plain JavaScript, but it's already built-in implementation. So what's a set? It's a concept that comes from mathematics, and it describes a collection of elements that are, first of all, unique, and usually they are unordered. But some implementations of sets can implement in order. For example, in JavaScript, the built-in set object has an order. And also, usually set is implemented as a hash map, but it's not a requirement. You can use, for example, linked list, but it will increase algorithmic complexity of main operations like add, delete, find. And yeah, you can imagine a set as some unordered entities or elements or nodes. And let's compare it to some real-world things that we usually see. Let's start with a bookshelf. So at home you probably have a bookshelf with a lot of books, or maybe a few of them, but all the books should be unique. Usually you don't keep one copy of a book, and if you want to represent this bookshelf as some structure in code, you may want to use a set, because all books are unique and you don't want to count them, for example. Same goes for a store, bookstore. They usually have a lot of copies of the same book on shelves, but in that case, if you want to count them, it's not a proper data structure to use. But if you want just to represent the unique books in the bookstore, you can use a set. What else? Power Rangers. You know, they are all unique, or maybe not that really, but at least we distinct them very clearly because of their suits. It's also a set of unique elements, and for example, if we would have multiple red Power Rangers or black Power Rangers or yellow, then set won't be very useful to represent that. But until they are just all unique, and we just want to use set to, for example, to show if they are there or not, if one ranger is, I don't know, alive or not, then set is good to go. Okay, that's pretty clear. Let's continue with operations. I went through different implementations of set, and I found multiple standard methods. It's add, delete, and has. Has just checks if element is there or not. And yeah, that's pretty clear. And we have optional things. There can be a lot of methods, optional methods, that you find in one implementation and won't find in another. And it depends on your purposes. So if you, for example, want to track the size of the set, then you just introduce a size method to, and size property to count it. There can be isEmpty to check if it's empty or not, map to go through all the elements, and clear just to make it empty. And when we talk about sets, we also talk about set algebra, which also comes from mathematics. So imagine we have four operations, and to illustrate them, I'll use two circles. It's like standard visual representation of set algebra. So the first circle, let's imagine that these are students. First, blue is a set of students that go to an IT class, and red is a set of students that go to a philosophy class. And they, of course, can intersect, but they're usually not the same set. First one is a union. Union will return everything from both sets. So we'll have this part, the intersecting part, and the red part. So we'll have students that go to any of that class or to both classes. Intersect. Intersect will return us only students in the middle that attend both classes. Difference will return everything except students that go to both classes. So it will be purely blue side and purely red side. And subset, a subset is a bit different. So we'll tell if all students that go to philosophy class are also attending the IT class. So it's called a subset. What about complexity? So set is pretty effective because it usually uses a hash map. So we have an insertion of big O of 1, same for deletion and same for search. So a hash map provides a very effective way of accessing elements or removing elements, because we have a key and we just address this key for anything, for insertion, for deletion, for search. But we'll cover this in a separate video about hash maps. Now we're going to implement it using plain JavaScript without using a built-in set object. So we have a constructor. We have two classes. First of all, it's mySet, which will represent all standard operations for a set, like add, delete, has. I already created the signature of methods, so all of them, they just accept some element. And we have a constructor. I decided not to, for example, you could create a constructor which accepts an array and create a set from an array, but it's just an improvement. I won't do that right now. And also I prepared a class called setAlgebra, which can be a separate class. I wouldn't move those methods in mySet, but we could do that. Instead, setAlgebra will have static methods. Let's make them static. They don't need to keep any state. And this class will describe all four operations for sets, which we call the setAlgebra. And also I prepared a test. Multiple tests. We will go through it. It just outputs the values, create set, and just calls all the operations that I listed. So let's start from the constructor. In our set, we need to keep values somewhere, and we'll use an object for that. So it will be a hash map where the key will be the element itself and the value will be just true. So we don't want to store anything else. If we want to add something, we just go with set and we provide an element. Let's assume that element is integer or string, so it's not something complex, but we could also improve it to be more complex. And we'll just make it true. What else? Delete. Delete is also very simple, or we can call a delete function for the same element. And has, we just will return if this set has own property element. So yeah, we're dealing with objects, and objects have their own their properties, default properties, and we're adding something new, so we need to check if it's our own property or it's something default. That's why we are calling has own property on the set. Yeah, that's pretty clear. What we could do here, we could track the size. If we would introduce a size variable, we could make it more complex. For example, we could check when we are adding that this property is not here, and then we'll increment size. And same thing for delete. If the element is there, we will call this delete, and we'll also decrement the size. But I decided not to add size here. Okay, unions. So how can we do a union between sets? Union will include elements from both sets. So we need to iterate through a set, and then we'll just first we'll create a new set, and then we'll iterate through both set 1 and set 2, which user will provide us, and we'll add elements to a new set. So let's first create it. It will be, I will call it just result, and it will be new mySet. It's empty, so now we're going to edit. We'll return result in the end. To iterate through the values, I'll use in function for in for element in set 1 set. So we need to address this, otherwise it will be just an object, not the object that we want, but the entire set. For element in set, and it complains because I didn't provide let, and we add it to the result add element. Yeah, and we also need to check if it's own property of a set. If set1 set has own property element, only then we'll add this property, this element to the resulting set. Okay, and we need to do the same with set number 2, so I'll just copy that. Set2 set. Okay, this is how we do a union. Intersection. We need to choose all elements that exist in both sets. Okay, so we'll also have const result new my set, and we will iterate only through set1. And we will make a check that we have this property in both sets. If set1 set has own property element and set2 has the same element, then we'll add it to the result. Okay, and we'll return the result. Difference. So we need to understand that the element, we need to iterate through both sets, and we need to understand which elements are not in both sets. Okay, so first we'll once again create the result set. Then we're gonna iterate first through set number 1, and we will check if it's an own property of set number 1 and not a property of a set number 2. And I think we'll do the same for set 2, because there can be elements that are only in set 2. We'll return the result and fix the second 4. Yeah, and vice versa. If set 2 has own property element and it's not in set 1, then we'll add it to the result. And subset. We need to understand if our set number 2 exists, like entirely exists in set number 1. If it is, then it should return true. Okay, once again, we're creating the result. That's the easiest part. And then we are going to go through a set number 2. So for that element, yeah, I'll just copy that. So I think we can follow the same logic. I'm trying to understand what logic should we follow here. We can do it like this. If an element is an own property of a set 2, but it's not in a set 1, we should return false right away. Otherwise, we'll return true. Let's write this: if set2 set has own property element and set1 set doesn't have it as a property, then it's not a subset. We will return false. Otherwise, when we'll check all the elements, it will just return true. Okay, let's run our tests. First of all, gonna just go through tests. We are creating a new set. We're console logging it, empty set, set1. Then we're adding 4, 5, 6, so 3 elements, and we are outputting a set after we did it, set1. Then we delete element number 5, not 5 with the key number, with the number 5, and we outputting the set with 2 elements, hopefully, and we are checking if the element which is number 6 is there, should be there. Then we're creating a set number 2. We're adding 6 and 9, only 2 elements there. We are console logging it. We're looking through a union of both sets, looking into intersection of those sets and difference. And then we are introducing my set, which has only 4, which also exists in set number 1. And we are checking 2 things here. If set 2 is a subset of set 1, it should be false, because set 2 has 9, which is not in set number 1. And we're checking the same for set 3 if it's a subset of set 1. And it should be, because it has only 1 element 4, which exists in set number 1. So it may sound complex, but let's just launch the code and see. Maybe we'll have some errors. No, we didn't have any errors. That's good. So let's check empty set. We have my set. Maybe make it bigger. So my set, and it's just an empty object. That's what we expect. After 3 elements, it's an object with 3 elements. They look like 4 as a key and 2 as a value. Then we remove 1 element, 5, and it's not here. That's good. And it has 6. That's true. Set number 2 is what we expect. Union of those sets is also what we expect. So 3 elements, 4, 6, 9. Intersection is only 6. That's good. Difference is 4 and 9, because 6 exists in both sets. And set 2 is a subset of set 1, false, and set 3 is a subset of set 1, true. Works like a charm. Now we'll compare this implementation to an implementation using a set with built-in set object. Now we're going to have use a set built-in structure in JavaScript to just replace our implementation with a more short one and maybe a more clear one. So what we do is that we create a new set, and this is built-in function, built-in object, so it should be there. We shouldn't care where to get it. We shouldn't create anything. And now we're just calling an add method for it. It's a built-in method in the object. And for delete, we are calling delete method. And for has, guess what? We're using a has method. So basically, we already have all these methods in the set, and this entire class is redundant. That's why we can remove it entirely. We can use set built-in structure. And I have an implementation of set algebra that was changed for using a new set, and it will be much faster. So let's see, the signature is the same. It's union, set1, set2. But when we create a result, it's not empty. It already creates a set and uses all the elements from set1. That's the syntax. If we pass something like this, set will be created with elements. It's iteratable. And set2, we just using for each here, and for each element we add it to the result, and we return the result. Super simple, much simpler than we had before. Intersection, pretty much the same. We're creating an empty set, and for each element we check if set2 has it. If yes, then we add it. Difference, it's about the same that we have, but syntax is a little bit different. So once again, for each, if element is not in set 2, then we add it, and vice versa for the set 2. If for each element, if an element is not in set 1, then we also add it. Okay, subset we can't use for each here because we need to break the loop. If something goes, if there is no element in set 1, if it's not a subset. So we are using let elements off, and yeah, it's also much shorter, and we use keys to get keys. By the way, we can use values for that because they will be equal to keys, and it's done to have the same methods for both set and map. Map is another structure that we'll cover in another lesson. So tests are basically the same, but a little bit shorter because we create a filled-in set from the very beginning. And let's just execute it. I expect it to be true because I already tested it before. Yeah, and it's true. The format is a little bit different. So here you can see that when we output it, it shows that it's a set of 3 elements, and then it lists the elements. So there is no like key value relations. There is no value equal to true, which looks a bit more clear. And yeah, everything else is the same. So this is implementation of a set using built-in set object. I hope it was interesting. There will be more lessons, and they will be also useful. So stay tuned.